Okay.
Looks like you have a few colleagues with you too.
Yes, yes, we have a few speakers with us.
Very good. I may have a couple of other judges joining in, but we only have about 15 minutes.
Right, sir.
And so I'm not expecting any presentation from you. I've had a chance to review all of your materials. I
All right.
wanted to have an opportunity just to ask you a few questions to help me better understand some of your design decisions and
Definitely, sir.
aspects of your rocket. Is that okay?
That's totally fine, sir.
Okay, good.
So just for confirmation, sir, we'll be just starting with the question and answer sessions directly, no presentation as such or a brief introduction that we have created.
Well, I've had a chance to see all of your material, and so I don't think I might have some questions about your overall kind of project goals, but we'll see. I don't want to take too much time on that. I'd much rather actually dive a little bit more deeply into just a couple of quick questions, okay? And then if we have time, we can maybe turn it around a little bit. Is that okay?
Definitely, sir.
Yeah. I think your payload vision, by the way, is really solid. I enjoyed reading your project documentation. I wanted to understand what your kind of rationale was for going with COTS motors first, and then you alluded to actually maybe moving to SRAD motor to follow. What is your general plan there, and why did you make the decision to go with COTS this time? As opposed to taking that extra step.
Right, so we have the perfect answer for that. So, sir, as you have reviewed our material, we are participating for the first time in Spaceport America Cup, and this is our first encounter in the field of rockets, sounding rockets, amateur rocketry. And we initially had planned various hybrid systems to incorporate, but Spaceport America Cup, we wrote several mails to Spaceport America Cup, and they said, since you are first time dealing in rockets, you should definitely go with 10,000 feet COTS solid rocket motor this time.
Okay.
So
okay, thank you. I was unaware that they had given you that guidance because I've not been involved with your team since the very beginning. They kind of shuffle us up a little bit towards the end of the program, right?
Right.
Could you explain to me what are the black powder restrictions in India? I'm assuming that due to the fireworks industry, doing things like even having black powder is considered probably a crime in the country, right? Am I close to the truth on that? When you were making your own powder and things along those lines,
yes, sir.
What was your rationale?
The black powder is illegal in India, so we had to make our own black powder charges. Like we chose a CO2 ejection charges, but since the CO2 ejection mechanism had black powder in it, so we had to make our own black powder using the raw materials. It is illegal to use the 4F black powder in India.
So when you were doing graphite-based black powder, basically, what kind of characterization testing did you do on that? One of the criticisms of a lot of black powder substitutes is it's hard to ignite, or it's got a different burn rate. When you're doing evaluation of your charges, even to act as a primary charge to release CO2, what kind of characterization did you do to kind of qualify, how many grams of your powder was required to yield the amount of force that you needed to drive a nail into a CO2 cartridge?
Yes, Lakshman, would you answer that?
So it was mostly a very trial and error based thing because we obviously couldn't get the actual black powder. So what we did was we did a trial and error iterative method. If you had in a lot of our reports, we had also added the pictures of our testing. So that's basically what we did. We sort of did a trial and error version of the test, and then finally arrived at the exact quantity that we required. It was a range. It wasn't a particular quantity as such, but it was something that we could use reliable.
So was your intent then? I can imagine checking in homemade black powder in your checked-in baggage coming to launch in Spaceport America would have been rather challenging. Was your intent to actually use black powder in this country?
Sir,
No, sir. We had a plan.
The thing that we thought of was that we were in communication with Animal Motor Works, and they said that they could help us out with these charges. So we used the crude black powders that we made here to test the system out and to see if it performs well. And then we were talking with them as to see what sort of characteristics they could provide us with. So we were trying to match our systems with theirs.
I see. So that's a piece of information that would have been beneficial to put in your final report, right? Is that the powder that you were manufacturing was really there to prove out your CO2 firing sequence, right? But then your intent would be to use black powder that you'd purchase on site in New Mexico, for example, or through a vendor that has very well known properties, right? That would have been very, I think, useful to include in your project report, just as a little bit of feedback. Okay.
Yeah. Thank you, sir.
What do you think was your biggest learning challenge over the past year in putting this project together? Okay, and let's not talk about payload. Let's think mostly just about rocketry. What's the biggest rocketry challenge you think that you've been facing?
All right, sir. So I think me and Dheeraj would be able to answer that because first of all, since our teammates are spread throughout India, so we couldn't come together as a team and assemble a rocket for testing or whatever purposes this is. So only one man or woman had to take the brunt of assembling all of it at their homes or at their convents, right? So first of all, since it's our first time in rocketry, as you asked, so our main source for incurring all of the knowledge were Apogee Rocket newsletters, all the information that is available on the net. And what largely helped us was the previous year reports or the winning teams that are available on Spaceport America Cup domain. So from all that, we had our basic concept design, to which we also applied our gained knowledge via Apogee Rocket newsletter or YouTube or the holy grail of propulsion or all of that aerodynamics book that you have. And regarding the manufacturing part, and also so when we have designed our concept, so that is one thing. But the other thing is to bring it into physicality. So that requires a lot of funds. And since our team is not very old, so we had a great amount of difficulty in raising the funds for that. So we had fundraiser in between, and successfully we were able to raise like around, maybe I think that was around $1,200. So that was a major help from all of the contributors. And regarding the integration of the rocket, when we were able to raise the money for that, and when we were able to send the parts for manufacturing, Dheeraj would like to carry that forward. How he carried out the process.
Those are all very good points. This is another little thing I think about when I think about top-down design, right? If you take a look at trade-off analysis for rockets, you know, it's typically at the highest level. There's a trade-off between what is the mission, right? What are the physical characteristics, and what's the cost or effort involved? And so when you think about how you make design decisions, why did you choose carbon fiber, right? As opposed to spinning your own aluminum, right? Those kinds, sharing that rationale as part of your trade-off analysis is a very good thing to do.
Yes,
your team may be more constrained around cost than others. I can only imagine how much it would cost to bring your team to the United States to fly and all this, right? So, you know, and that's a real practical, it's a heavyweight kind of factor in your system design. And being very candid about that as how it is kind of motivation for certain of the things that you are doing yourselves, or certain materials that you're choosing because of availability, or things along those lines, demonstrates a very good high-level design, right? And so that's one of the pieces of feedback that I wanted to share with you today. With that said, though, I've really enjoyed reading your report. I think you've got a rocket that's maybe almost ready to fly, right? And I'm hoping that you know, you have a chance to complete your tests, and that we do have a chance to kind of watch your rocket fly one of these days. And congratulations on some good work.
Thank you, sir.
Thank you so much, sir.
Thank you, sir.
Do you have any last questions for me? We have maybe just a couple minutes left. Any questions?
Okay, sir.
So-
Yeah, Dheeraj, go ahead.
So, just a general question, sir. How have we performed? Like this was our first time in SA Cup. We don't have any um, trademarks like we should have performed this good. So can you please let us know what improvements can be done from our side so that the next time we can do much better than this time? And
Yeah. So one of the key factors that that IREC looks for is student developed parts, so SRAD parts, right?
yes, sir.
But the logic of walking before you run, right? And a new team kind of building expertise and doing all that makes perfectly good sense. It's going to be very hard to compete though, head to head with other teams that are completely SRAD, from motors to everything, right? So
Yes.
I really appreciated how much of your own parts were in the design. But
Yes, sir.
if you stay on that track where you're continuing to demonstrate innovation and not kind of resting on your laurels from last year, or
Yes, sir.
reusing a design from last year, or worse is like you reusing a design but don't actually share what that design is for the judges next year, right? Those kinds of things are kind of barriers that you have to think about. So even if you're reusing stuff, you actually have to remember what the rationale was and include that in your design, right? So those are just a couple of things to think about as you evolve to next year. Is how do you maintain a solid pace of innovation? How do you add even more engineering? And how do you make sure you document all the little bits, including why you're doing the things that you do? Does that help?
Yes, sir. Yes, sir. Yes, sir. Sure, sir. Thank you so much, sir.
Yeah.
Yes, sir.
I think we're at the bottom of our 15 minutes then. Thank you very much again. And I appreciate you taking time. You're middle of the night out there. It's got to be difficult for you to get to be dialing in. It's not as hard for me. But thank you very much. I appreciate your time today.
Thank you, sir. Thank you for your
Thank
time.
you so much, sir.
Yeah, no worries.
Thank you, sir.
Okay,
Thank
bye
you,
now.
sir.
Thank you, sir.
Bye, sir.